Hi, everyone. This is going to be a combination of section 2.2 into section 2.3. I posted this graph on Classroom. I think it will be very helpful for you if you choose to take notes. I don't collect your notes. Take notes, don't take notes, it's up to you. Although I do think that if you take notes, obviously you will have a better understanding of the material. So this is the graph I'm going to be using for the bulk of the lesson. And it's just some function. It passes the vertical line test. So I just made it up. It's got some funny points, etc. And we're going to do a little bit of analysis of this graph. So for example, some basic questions such as, what is the f, uh-oh, you can't see that. How about we go there? The f of -7. So I'm going to look at the graph. I'm going to find x is -7, y is 3. This color is not the best. We'll try a different one. What if I asked you to find the f of 10? So again, you find 10 on the graph. The f of 10 is 2. Okay, working backwards. What if I asked you, where is the function equal to 4? So if I ask you, where is the function equal to 4? That would be when x is 6 and when x is 8. Oops, I'm gonna try and, sorry, trying to focus it a little bit better. So this is where x is 6 and where x equals 8. And if you want to just write 6, 8, no problem. So these are all very basic questions. Of course, when we look at graphs, the most important thing we want to know is domain and range. So I abbreviate D and R. Okay, so remember, domain are the x values. So the lowest x value we have on this graph appears to be -7. And it is smooth and continuous, no breaks, no gaps, no asymptotes, no holes, all the way till x is 10. So the domain is -7, less than or equal to x, less than or equal to 10. And by the way, if you find a mistake that I make in the notes, which of course is bound to happen, we'll have time to go over your questions, or you can send me a polite email saying, Ms. Babiak, you need to learn how to count. The answer was supposed to be 6, not 7, or whatever. You know what I mean. The range. So the range are the y values. So it appears that my lowest y value is -1. And again, it's smooth and continuous, no holes, no asymptotes. We're all good to go. It appears that my highest y value is 5. So I would write that as -1, less than or equal to y, less than or equal to 5. Okay, so the new thing that we're going to talk about, slightly new thing we're going to talk about, are maxes and mins. And we're going to do this much more extensively on the calculator, but today's just going to be a little bit of an intro. So I'm going to want to know, where is the maximum on this graph? Where are the minimums on this graph? And you can have multiple maxes and minimums. So how is that possible? So I'm going to look at stages of this graph, and there are several, let's say sections. Stages is the wrong word. There are several sections of this graph. There's the section from where x is -7 up to where x is -2. That's a section of the graph. And I know I said we're going to talk about max and mins, but I changed my mind. Let's talk about increasing and decreasing instead. So the reason I know that from -7 to -2 is a section, because the graph appears to be increasing in value, but then when x hits -2, the graph is decreasing in value. And you'll notice I have this 0.01. I put it there on purpose. The 0.01 is also known as the, exactly, the y-intercept. And so it's going to decrease until I get to the 0.3, -1. And that's another section of my graph. So you draw in the remaining sections. should have drawn in a section. There's actually 2 more sections. From the 0.64 to the 0.84 is indeed its own section. It's just called a constant. The y values are not increasing or decreasing, they're constant. Okay, so let me try and just do this a little bit. Okay, I think we would agree that if I start at the point -7.3, and I always like to look at it as like I'm going for a walk. If I'm going for a walk, I am walking uphill. And remember, we always go from left to right. Always go from the smaller x values to the larger x values. So as I go from left to right, the value of the y's are increasing. Okay, and as I go from the point at -2.5, I'm decreasing to 0.1, but I continue to decrease until I get to 3, -1. So this whole section, it's like if I was at this top point here, I would like be sliding down, and I would be decreasing. And I'm kind of lazy. I don't want to write the whole thing out. So I'm just going to put a DEC for decreasing. And then from 3, -1 up to 6.4, I am increasing. And in the middle here, I am constant. And then I am decreasing. Okay. You'll have an opportunity to ask questions after the video is over. Okay. So here's what's going to happen. Great. We have this point from -7.3 to the point -2.5, I am increasing. That is not how we write the notation. So this part is going to be new, I think, for just about everybody. I want to describe what's happening to y as x goes from left to right. As x goes from left to right, what is happening to the y values? So as x goes from -7 to -2, y is increasing. So I'm just going to put here INC for increasing. I hope my pen still works. Oops, you can't see it. Sorry, not so good with the colors here today. Let me try this again. Okay, so I do not write -7.3 like with an arrow to -2.5. That's incorrect. Your answer is only x values. You are going to describe intervals of x and x only. So the function is increasing from x is -7 to x is -2. The function is increasing when x is -7 up to x is -2. Oh, you can't see that. Sorry. I didn't do a very good job here. I apologize. Next video will be better. I'm not going to put any like other stuff here for right now. I'm going to just hold off on that. It's also increasing when x is 3 up to when x is 6. We're increasing from when x is 3 to x is 6. Okay. We have parentheses and we have brackets. Parentheses are not included. Brackets are included. Okay, included, not included. Let's talk about not included first. Not included would be things like open circles and infinity. Open circles and infinity. Included would be closed circles, for example. These are closed circles, but they're not. Okay, wow, Ms. Babiak, you've totally lost me. Okay, here we go. From -7 up to -2, x is -7 to -2, the graph is increasing. But then at -2, when x is -2, the graph starts to decrease. This right here is called a turning point. The graph is switching from increasing to decreasing, and that is called a turning point. And turning points are always parentheses, always. So 3x is 3. This is a turning point. The graph is switching from decreasing to increasing. This is a turning point. When you get to 6, 6 is a turning point. The graph is switching from increasing to constant. 6 is a turning point. Essentially, graphs have a lot of turning points. At the point 84, also a turning point. When x is 8, we have a turning point. When x is 10, the graph ends. It's just decreasing, the graph ends. Okay, so let's kind of pull this all together. A turning point is what happens when the graph is changing from increasing to decreasing or constant. Those are turning points, and they're always a parenthesis. So when I look here at my increasing, we said that the graph was increasing from when x was -7 to -2. -2 is a turning point, parenthesis. I'll get back to -7 in a second. X is 3 to x is 6. X is 3, turning point, parenthesis. I hope I'm not making you nauseous. X is 6. When x is 6, it switches from increasing to a constant. That's a turning point, parenthesis. We're going to put in union. At -7, that's where the graph starts. There's no turning point there. It's the beginning of the graph. That is a bracket. This is where the graph is increasing. Along the interval between -7, -2. Notice that this is not an ordered pair on the graph. This does not represent an ordered pair on the graph. Okay, so let's try decreasing. I apologize, I'll do a better job next video. I haven't done a video like this in a really long time, which is no excuse. I'll get better for the next one. Okay, decreasing. It decreases at when x is -2 down to where x is 3. I only care about the x values. So from -2, x is -2 down to x is +3, we are decreasing. Those are both turning points. It is decreasing when x is 8 to where x is 10. Between the interval of 8 and 10, we are decreasing. 8 is a turning point, open parenthesis. 10, the graph ends at 10. It is a bracket. Constant, both turning points. It's constant between 6 and 8, but 6 is a turning point because it went from increasing to constant. 8 is a turning point because it's going from constant to decreasing. So 6, 8. Okay, so that is increasing and decreasing turning points, the basic graph. Let's look at the maxes. Let's look at the maxes and the mins. So try and get a better color over here. We have a maximum at -2, 5. Maximums are ordered pairs. We have a minimum at 3, -1. Okay. We also have what we call local maxes and mins. So you know how we divided this all up in these sections? We divided this whole graph up into sections. If you look at the section between 3, when x is 3, and when x is 6, when x is 3 to when x is 6, 6 comma 4 is considered to be a local max. For this little section right here, it is the high point. It's not the overall high point, but it is indeed a high point. So we call 6, 4 to be a local max. Endpoints are neither local maxes or mins. The endpoints are neither local maxes nor are they mins. Okay. So that's a basic introduction to maxes and mins, very basic. We're going to talk about it much more extensively. And then the main thing that I wanted to stress right now is this whole idea of interval notation, and then the parentheses and the brackets. And again, we'll get a lot more practice with that as well. Okay, the next thing we're going to talk about are odd and even functions. If you memorize it, you're going to struggle. Okay. Odd functions have what we call origin symmetry. Even functions have y-axis symmetry. There's no name for x-axis symmetry. There's no name for x-axis symmetry. Okay. You have some function. Let's start with x cubed. I'm about to break a major rule of mine, and I'm drawing a crappy graph on graph paper. I should be using a nice little, okay, but this is y equals x cubed. Y equals x cubed has origin symmetry. Y equals x cubed has origin symmetry, which means that when you fold it along the x-axis and the y-axis, doesn't matter which order you do it in, you get the same graph. Okay, the test. How do you show this algebraically? The opposite of x. I like to say opposite instead of negative. If I plug in the opposite of x, so any graph, whatever, right? So here is everything's positive. Here, x is negative, y is positive. X is positive. Oh, you can't see that. Let's try that again. X is positive, x is negative. You get the same y value. That would be y-axis symmetry. If I start in quadrant here and I flip over, that would be y-axis symmetry, which means that when I have the opposite of x, I get the same exact value for y. Positive, negative, those are opposites. When I plug in the opposite of x, I get the same value for y. That is y-axis symmetry. Okay, so what happens when I plug in the opposite of x? If I get the same value for y, I'm plugging in the opposite of x, but I'm getting the same overall value of the function. That is even. A parabola is a fantastic example of an even function. Okay. If I plug in the opposite of x, so remember I said how you fold along the y-axis and then you fold along the x-axis and you get the same thing. It doesn't matter which one you do first. So if I end up in the third quadrant, If I do a flip over y, flip over x, I plug in the opposite for x, positive, negative, and I get the opposite of the function, that is considered to be odd. What? Okay, so let's look at x cubed. So I have given the f of x equals x cubed. That's supposed to be a 3. I'm not sure if you can see it. This is a 3. So given that the function is x cubed, we already know it has origin symmetry. I just drew it right here. When you plug in, so take the given function, plug in negative x. So all I did was I plugged in negative x for x. So I took out the x and I plugged in negative x. I took out the x. I plugged in negative x. Let's evaluate that. Well, negative x times negative x times negative x is negative x cubed. Negative x times negative x times negative x is negative x cubed. These are opposites. Therefore, the function is odd. What about something like 1 over x? It's a rational function. 1 over x is a rational function. It has asymptotes at x equals 0, y equals 0. So my question to you is odd, even, or neither. Start by plugging in negative x and see what you get. The test always involves negative x. So plug in negative x first, see what you get. Do you get the original function? Do you get the opposite of the original function? Do you get neither? If I plug in negative x, that's 1 over negative x, which is, of course, icky math. That's gross. We don't leave a negative in the denominator. So this is negative 1 over x. Isn't that the opposite of what we started with? That's the opposite of what we started with. So in this particular case, when I plug in negative x, I get the opposite of what I started with. Therefore, this is odd. Therefore, 3 dots in a triangle formation. Okay, I will, when this video is over, I will be online to answer your questions.